Have you ever wondered how we can predict the nature of the roots of a quadratic equation? How can a simple mathematical concept provide insights into real life situations? Today we delve into the fascinating world of nature of roots of a quadratic equation and discover its practical application in our day-to-day lives. But first, let us refresh our memory. A quadratic equation is an equation of the form ax squared plus bx plus c equal to 0, where a, b and c are numbers. We have found its roots using various methods, and one of the methods is using the quadratic formula, which gives the roots of this equation to be x equal to minus b plus minus under root b square minus 4ac upon 2a. To understand the nature of roots, we will explore a powerful tool called the discriminant of the equation. This expression inside the square root is known as the discriminant and is denoted by d or the Greek letter delta. Let us consider the various possibilities. Number 1, when the value of d is greater than 0, then under root b square minus 4ac is a real number. So the values of x are minus b plus under root d upon 2a and minus b minus under root d upon 2a, which are clearly distinct values. So in this case, the roots are real and distinct. Next comes when d is equal to 0. If d is 0, then root d is also 0, and hence the roots are real and equal, and x equal to minus b upon 2a is the unique solution of the equation. Now the only possibility that remains is d less than 0. Will square root d be a real number in this case? Let's check out. Say root d is equal to x. This implies d is equal to x square, but this is not possible because d is negative whereas square is always positive. So this indicates that root d is not real. Such numbers are called imaginary numbers. You will learn more about these numbers later in mathematics. So when d is less than 0, real roots do not exist. So we have discussed all the three possibilities. Let's now try some problems based on the nature of roots. Consider the equation 2x square minus 3x plus 5 equal to 0. In order to find discriminant, we need to check the standard form first. This equation is already in standard form as the powers of x are in decreasing order. So comparing it with the standard form ax square plus bx plus c equal to 0, a is 2, b is minus 3 and c is 5. Therefore, discriminant will be b square minus 4ac. Putting the values minus 3 square minus 4 into 2 into 5, which is 9 minus 40 equal to minus 31. As this is less than 0, it means this equation has no real roots. In the next one, we have 3x square minus 4 root 3x plus 4 equal to 0. Can you give it a try? Complete it quickly. Let's see if you can do it. So everybody got discriminant equal to 0, and it means that it has real and equal roots, or you can say unique solution. The next example is a little different in the sense that we don't have numbers here but a constant k. But no worries. We have to follow the same method. Here x is the variable and k is the constant. So comparing with ax square plus bx plus c equal to 0, we get a is k square, b is k and c is 1. So d is k square minus 4 into k square into 1, which is k square minus 4k square. These are like terms. So 1 minus 4 is minus 3, so we get minus 3k square. Now as this is not a number, we have to decide whether it is positive or negative. Clearly square of any number is always positive, so k square will be positive, and when you multiply it by minus 3, we get a negative answer. This means that d is less than 0. Clear? So this equation has no real roots. Next comes 2 inside brackets a square plus b square into x square plus 2 inside brackets a plus b into x plus 1 equal to 0. Looks complicated? You just have to be a little more careful. Observe what is the coefficient of x square? Yes, this one. So a is equal to 2 inside brackets a square plus b square. We can simplify it further by multiplying 2 with each term of the bracket, and we have 2a square plus 2b square. What about coefficient of x? Right, b is equal to 2 into a plus b. Opening the brackets, it becomes 2a plus 2b. And c is the constant term, which is equal to 1. So let's calculate d. 2a plus 2b whole square minus 4 into 2a square plus 2b square into 1. Now this bracket is the identity a plus b whole square. So expanding it, we get 2a whole square plus 2b whole square plus 2 into 2a into 2b. Minus 4 into 1 is minus 4. Multiplying it with every term of the bracket, we have minus 8a square minus 8b square. Solving further, 4a square plus 4b square plus 8ab minus 8a square minus 8b square. 4a square and minus 8a square are like terms. 4 minus 8 is minus 4. So we get minus 4a square on solving. Similarly, adding the b square terms, we get minus 4b square and then plus 8ab. Now if you look at this form, we cannot decide from here whether it is positive or negative. So we will convert it into a form where we can easily decide. Can you see something which is multiplied in every term? Yes, it is 4. And as the first term is negative, let's take minus sign common. So taking minus 4 common, we are left with a square from the first term plus b square from the second and minus 2ab from the third. Is this some identity? Correct. It is a minus b whole square. So this way we get this value of discriminant. Now a minus b whole square is a square, and so it is always positive. And when we multiply it with a negative number, minus 4, the answer is negative. So this tells us that d is negative, and hence the equation has no real roots. Next, let's try some questions where we will find the value of k for which the equation has equal roots. The first one is 2x square plus kx plus 3 equal to 0, which is already in standard form. So a is 2, b is k, and c is 3. As this equation has equal roots, discriminant must be 0, which means that b square minus 4ac is 0. Let us put the values and simplify it further. So we get k square minus 4 into 2 into 3 equal to 0, or k square minus 24 is equal to 0. This means k square is 24. Taking square root on both the sides, we have k equal to plus minus under root 24. 24 can be written as 2 into 2 into 6 and has repeated factors. So the 2 will come out, and we finally have k equal to plus minus 2 root 6. So there are two values of k for which this given equation will have equal real roots. Now this one, is it in standard form? No. There are brackets in this equation, so we will first open the brackets and simplify it. The outer term will be multiplied with each term inside one by one, and we have kx into x equal to kx square minus kx into 2, that is 2kx, plus 6 equal to 0. You must check the standard form before you find the values of a, b and c. So a is k, b is minus 2k, and c is 6. As the roots are given equal, d is 0, which gives us minus 2k whole square minus 4 into k into 6 is equal to 0, or 4k square minus 24k equal to 0. As this is a quadratic equation in itself, we'll get two values of k. To simplify it, let's take common. You can observe 4k is a common factor. So we get 4k into k minus 6 equal to 0. If product of two numbers is 0, one of them must be 0. So this implies 4k equal to 0 or k minus 6 equal to 0, which further gives k equal to 0 or k equal to 6. We will reject k equal to 0. Why? Because this is not possible. If we put the value of k equal to 0 in the given equation, it will reduce to 6 equal to 0, which is neither a quadratic equation nor true. Understood? So the value of k is 6. Now this one comes with a little twist. Instead of giving the nature of roots, we are given that 3 is a root of this equation. So let's first find out the discriminant. We have a equal to 2, b equal to 1 and c equal to k. So d is b square minus 4ac equal to 1 square minus 4 into 2 into k, which is 1 minus 8k. Now we have to find out the value of k so that 3 is a root of this equation. By quadratic formula, roots are x equal to minus b plus minus under root d over 2a. Putting the values, 3 is equal to minus 1 plus minus under root 1 minus 8k upon 2 into 2. Solving this equation will give us the value of k. We have 3 equal to minus 1 plus minus under root 1 minus 8k upon 4. 4 goes and multiplies on the other side. So 3 into 4 is equal to minus 1 plus minus under root 1 minus 8k. Minus 1 goes and becomes plus 1 on the other side. So 12 plus 1 is equal to plus minus under root 1 minus 8k. Squaring both sides, 13 square is equal to plus minus under root 1 minus 8k square. The square root vanishes when we take square. Further, 169 minus 1 is equal to minus 8k, or 168 is equal to minus 8k. Taking minus 8 to the other side, 168 upon minus 8 is equal to k. Simplifying, we get k is equal to minus 21. So from these examples, you must have understood how knowing the nature of the roots helps us in deciding whether and when a situation is possible. Now you may be wondering, how does this concept relate to our day-to-day life? From calculating the trajectory of a projectile to maximizing the profit in business, from finding the vertex of a parabola to applications in engineering, the nature of roots guides us through important decision-making processes. Let's explore a few such situations. Is it possible to design a rectangular mango grove whose length is twice its breadth and area is 800 meters square? If so, find its dimensions. Let us first express this situation in the form of a quadratic equation. As you can see, length depends on the breadth, so let us take the breadth as x. So length will be twice of x, that is 2x. You know that the area of a rectangle is L into B. So putting the values here, we get 2x into x is equal to 800, or 2x square is equal to 800. Therefore, x square is equal to 800 upon 2, that is 400. Taking square root, x is equal to plus minus under root 400, that is plus minus 20. Now we will reject the value minus 20 as it is the length and length cannot be negative. So x is 20 meters. So we have obtained a real value of x that satisfies this quadratic equation. This means that it is possible to design such a grove with these given conditions, and its breadth will be 20 meters and length will be 2 into 20, that is 40 meters. Now let us check whether the following situation is possible. The sum of ages of the two friends is given 20 years, and 4 years ago the product of their ages was 48. To express this situation as a quadratic equation, let us take the age of first friend be x years. Therefore, the age of the second friend will be 20 minus x, as the sum of their ages is 20. 4 years ago, the age of the first friend would be obtained by subtracting 4 from the present age, so it is x minus 4. Similarly, age of the second friend will be 20 minus x minus 4, which simplifies to 16 minus x. As per the question, product of these ages is 48. Therefore, x minus 4 into 16 minus x is 48. Open these brackets. Each term of the first bracket will multiply to each term of the second bracket one by one. So we get 16x minus x square minus 64 plus 4x is equal to 48. 16x and 4x will add to get 20x. So minus x square plus 20x minus 64 minus 48 is equal to 0. Or minus x square plus 20x minus 112 is equal to 0. The first term being negative, we can simplify it by multiplying throughout by minus 1. So we get x square minus 20x plus 112 is equal to 0. Now let's calculate d. So we have 400 minus 4 into 1 into 112, or 400 minus 448, which is equal to minus 48. Clearly discriminant is less than 0. It means the equation has no real roots, and hence we find that this situation is not possible. Now let's check out the next situation. We are not given length or breadth of this park, but perimeter and area depend on length and breadth. So let us take the breadth as x. Perimeter is 2 into L plus B. So we have 2 into L plus B is equal to 80. Or L plus x is equal to 80 upon 2, that is 40. Therefore, L is equal to 40 minus x. According to question, area of the park is 400 meters square. So L into B is 400. Using the values, 40 minus x into x is equal to 400. X will multiply with each term of the bracket. So we have 40x minus x square equal to 400. X square term being negative, we can multiply throughout by minus 1, and we get the standard form x square minus 40x plus 400 is equal to 0. Comparing, b square minus 4ac is equal to minus 40 whole square minus 4 into 1 into 400, or 1600 minus 1600, which is equal to 0. So clearly this equation has equal and real roots. Therefore, it is possible to design this rectangular park. We can find its dimension using the quadratic formula, according to which x is equal to 40 plus minus 0 upon 2, or 40 upon 2, that is 20. So the breadth of the park will be 20 meters. And length will be 40 minus 20, which is again 20 meters. So this was all for today. I hope you enjoyed the session. Click on this link if you want to know more about practical applications of quadratic equations. Please like, share and subscribe for more such videos. Take care and goodbye.